Good morning. After the last video I had talking about the net benefits page, a reader came back and pointed out what appeared to be a contradiction. Now, it's not quite a contradiction, it is a clarification. His issue was on the suggestion page, one particular antibiotic was a recommended to take. On the page I had created, it was a don't take. So today I want to walk through the example of how computations can be done, and there are hundreds literally of possible ways of doing it, different algorithms, different attitudes, different interpretation. To answer his question, I created a page and actually added some more information on the page so that you can get a better idea of how I'm doing things and some of the choices. Okay, so let's take a look at a sample. A sample here we have bacteria A to H, and I'm using the cutoff-Moultrie limits, and we see how far high or low from what the normal range is they are. And for example, we are 1,000 bacteria count above. After that, we have log base 10 of that number, which happens to be 3. You literally just count the number of zeros to get 3. 100 high. We have some people who are low. We have one particular thing which is very high. This could be something like at a family or genus or even order level is particularly high. And we have something else which is really high. And we next have a substance, some substance, be it antibiotic, be it probiotic, whatever, and it either increases or decreases. We don't know how much it increases or decreases because in general the study does not specify that, and even if they do, there's so much context around it that the numbers become meaningless. We only know in general it increases or decreases for a sample of people which were given it, or in some cases animals, because some of the data comes from vet studies. And then we have after it confidence. Confidence represents the number of studies that are being done, and hence how much confident are we that this will actually increase or decrease. For example, let's take study B. Study B may have a confidence factor of 0.8, indicating perhaps just one study has been done. A, for bacteria A, is 0.04, is half of that, and that may be because there's been 2 studies saying it improved and 1 study that says it doesn't improve, and that result here. Here we have 1.2. This could be 3 or 4 or 5 studies all saying the same type of shift. And so we go down, and depending on the number of studies we have and whether or not their results agree or disagree, we assign a confidence number. That is some ways a subjective way. I have an algorithm I use depending on the number of studies and whether or not it agrees or disagrees, etc. And I get a computed confidence number. Some people may want to go and read the article and make a subjective assignment about it. That's fine, doesn't matter. So we have that, and what I had originally put up there was a pure category 1. And category 1 is a very simple one to understand. It says, okay, give it a 1 if it shifts things in the right direction, and give it a -1 if it shifts things in the wrong direction. For example, we have high of C, and it is reported to increase C, so we have a -1 there. So we mark all of them, we sum up, and we have the net benefit being 1. It impacts a ton of stuff, but the net result is 1, and if you take an average of all the above, it's sitting about 0.01. Usually you would like to see the average sitting about 0.7 or 0.8 or higher, indicating that the majority of benefits is there for the majority of things. Here you have a bit of randomness going back and forth, and you're not greatly confident about whether or not it will happen or not. So that's method 1, pure category. You just see, does it help increase or decrease this bacteria? This is often the type of logic people will use when they first get into the microbiome. Oh, it improves this, or it decreases that, and do a simple logic plus minus when you get a whole stack of different things impacted, a whole stack of things you want to change. The easiest calculation, just go through and check them off. Not necessarily the best, I don't think it's the best, but it's there as a check, as a reference point. Next is you take the amount. So we have it's high, it decreases it, so the net benefit is basically we're going to shift 1,000 bacteria more in the right direction, 100 more in the right direction, 10 in the wrong direction. We have a minus 100 and minus 1,000 in the wrong direction, positive, etc. So all it does is takes this, and instead of putting 1 or that, we take the result or the last number and multiply by how many we have. And now we can go on add up, and we get negative 9998 as the sum of it. And in this case, because we are doing it by bacterial count, this indicates basically the number of bacteria which could be impacted. And we now go and oops, I have a typo somewhere in there. I shouldn't be that number. I'll fix the page, but basically it's that same concept. I think yeah. So I need to update that page, which is fine. One reason I do videos is often I catch errors which aren't apparent doing it directly. Okay, now you will see that this particular single bacteria has a whopping big impact, but we also see we have relatively low confidence in it. It becomes a little bit dicey whether or not we should rely on this or not, which is why I use the log method, which is to calculate the log and use the log. What it does is it dampens down the effect of having a high number. It makes pure number less distorting of the results. So when we do the log amount, we go down, we see things are improved, and there. Okay, sorry for the quick interruption. I wanted to check out this, and the result is I actually have an extra 0 there, but everything else is done correctly. I had a transcription error. Okay, so now we have that, and we end up with -1. But we wait, just like for infomercial, wait, there's more. If we actually add in the confidence factor, we end up with a more complicated formula, and we end up having it modify so that yes, it modified by this amount, but because we are not so sure it will do it, we decrease the value of it. Sort of, I'm trying to think of a clear example. It's like betting on races, because in some ways you are doing that. You are betting on race, and the odds of racing is 0.4 or 1.2, and thereby you condition your bet amount, in this case the log number, by to see whether or not this distribution of bets is a good one or a bad one, in which case the net result is a 1.9, and we have a 0.3, which means okay, it's a benefit. So 2 of them are going one way, 2 of them are going the other way. Now what we have is actually a stack of different numbers with no known demonstrated formulas to combine them. We have the number of bacteria above or below what we want it to be. We can do computations on this, apply formulas to scale it, in which case I use a log, mainly because something called logistic regression and other things find that log of value seems to work very well for a whole bunch of real world problems, which hence my preference to use logs. We have increase or decrease, which is basically a binary either or, but it's not absolutely clear because we have studies with contradictory results. So the result is we have to put a confidence factor on it. And now we have basically 2 numbers to be combined and some sort of net result computed, and what we have as shown is a bit of a hodgepodge. It's all over the place. Okay, so now let's go over and do two things. Let's go over and log into our biome site example. Thank you again, Rose, for providing them. And what we have here is we have to this page refer to 2 points. If you go in and just do a quick lookup, you will see it's cited here at recommended readings, explaining how the computations are done, and puts a caveat on there which is more explanation. So basically saying, okay, this is not proven science, it's a mathematical model. Just gives information about how the model is being done. It just gives general caveats about the nature of the data. So that is one spot you will find this page reference to. The other one is the impact of microbiome. Before I had done a single number, and now I have multiple numbers. So if I go and search for results, oh joy, give me a second, I need to adjust the page. Oops. That is over in the wrong spot. And let's say we put in the word mono cycling. We see it down below, so I will uncheck this one. And notice that with nothing, we have no values calculated at all. I click up here to do an update. And what we do is we see the net result. In this case, for this particular sample, monocycline does not look like a particularly good choice. Let's take a look at, let's try if I've typed it correctly. Okay, I haven't. BIF. Okay, that's just word, decide the word probiotics. And we have a whole bunch of probiotics there. So now what? I can go down and select one of them, like Magnesium, which is one of my favorite. I'll uncheck here so that we'll basically switch over. And we see what the net benefit is, and it's not particularly looking good. We can go down and take something, another different probiotic, and see what its impact is. And again, it's not particularly good. Let's take something like Symbol 2. Notice what I'm doing is I'm checking down, doing a search, checking below, doing an update. Oh, absolutely no information. For outliers for this particular person, Symbol 4, known impact, has no match to any of the bacteria that the person has. Let's try Mutaflora. And again, we have a negative impact. And let's try one more with little animus. Voila! We now have a probiotic which will benefit, which is theoretically implied to benefit the person. We have also gone through and done. Now, if we go over to the samples and go and take a look at MECFS, and let's see, I haven't tried this before, so we may have a see if we have any included. No, we don't have any included there. In that list, could go back in and do a custom suggestion, and I believe it was the first one I was working from. So I'm going to do advanced suggestions, and I'm going to probably show one of the problems contradictory results. I'm going to just go down there, cutoff Molotov range, which is my standard nowadays. And there we have it. And we do have the Colostrum verticum showing up there as a positive, but it's a low positive. Bifidal there is high. Let's go back here. Okay, we can go back and try that particular probiotic and see what its benefits is by itself. Again, we use the first example. And that was Animus lactis, so there. So I'll go and there. Notice the value is 219.6. Let's see how consistent we are in our. Okay, so we end up with approximately the same range of values. So that is it. And that basically shows it. We may have inconsistency between suggestions and these net benefits. These net benefits are calculating in very simple straight method as illustrated on this page. It again gives you suggestions or factors considered. It does not provide definitive answers, but it does at least gives you a understanding of how I'm doing my calculation of the benefits, or how I calculate what is predicted to help or not. Not simple. We don't know the magic formula. For the suggestions, I'm doing the best. The algorithm which I have the greatest confidence in is probably being close to correct. And there, I've tried category. The results were less than desirable because it totally ignores the size. Taking it by the size, a couple of them just scaled things. If you have one which is particularly high or particularly low, it just totally dominates the suggestions. And I don't like that because it's almost, I should say, it's almost a too simplistic solution to just look at the worst case. The log thing gives a more balanced view. Adding in the confidence interval makes it probably more accurate because we don't know whether or not these increase or decrease are correct. And after reading enough studies where you have contradictory results between two studies on the same substance, on the same bacteria, you go, huh? And the reason is often very simple. Different diet. One is a Chinese study, one is a French study. They may also be connected with somebody who has a particular medical condition in one case and different medical condition in another. Both of those impact bacteria shifts, so we end up getting into this absolute quagmire. Of course, you could say, oh, just use the absolute good and clean study. And my response to you is simple. I would love to, I prefer to. We don't have them. That's the problem. We don't have them, and we having to work with what information is available until such time as a lot more studies are done. I mean a lot more. Okay, that's it. That was my morning spiel for the day. Have a good one, and hopefully you understand a little bit better of how I'm doing stuff.